Okay, everybody ready? What's the largest two-digit number?
99.
Smallest is 00. So how many two-digit numbers are there?
100.
100. So if there's 100 two-digit numbers, that means that three-digit numbers, there better be more. Do you guys follow me? So change your opinion about some things? So think about it like this. Here's my phone. I'm gonna pick a PIN number. What's the first thing I do?
Enter it.
Enter what?
The first number?
Yeah. How many options do I have for my first number?
99, 100.
I'm doing this. How many choices do I? Everyone, get your phone out. Take a look. Freaking get your phone. No, get your phone out.
Yeah. I got Face ID.
I got this.
So, yeah, how many options are there for my first pin?
10.
10. There's 10 options. What's the next thing I do?
We forgot. Take another code.
Hit another one. How many options are there? How many times am I going to do this?
3 times.
One more time. What do I do these numbers? Multiply. 1,000. Does that seem like it makes more sense?
Yes.
If a two-digit number is 100, three-digit number should be 1,000.
There's 1,000 possible things.
There are. And you know what? My sister bought some new luggage when we were in Galapagos because her other one broke. But the little lock didn't have, they couldn't remember what the lock thing was, so they gave her a lock. And we're going to dinner. I'm like, oh, I'll just play with it. I went through every one of those 1,000 numbers. Actually, I went through 803 of them before I finally found it. Yeah. But it's doable, right?
So
you just try.
So if you were trying to figure out how
It took me, well, I was talking and eating too, but it took me like 90% of lunch. Just flip through it. What was that? Each one takes like 10 seconds. You just flip to the next one and you try. Flip to the next one and you try. Flip to the next one and you try. It doesn't take that long.
That's true, but you have to think through that.
They my family thought it was crazy, but they know that for a long time. It's not a problem. Okay, next. Counting rules. Factorial. Write it down. Factorial is the product of all the positive numbers from one to a number. It's also the number of ways of arranging n items. How do you find factorial? You take the number and you multiply down to 1. So for example, 3 factorial is 3 times 2 times 1, 6. That's the number of ways of arranging 3 items. Why is it? So here, red, blue, white can be arranged 6 ways because there are 3 options for my first letter, right? For the first one, red, white, or blue. Once I pick one, there's 2 options for the second one. And once I pick that, there's only 1 option for the third. So 3 options and then 2 options and then 1 option. You guys find 4 factorial. Oh, and please note that 0 factorial is 1. Not 0. Oh, shoot. 0 factorial is 1. Move this over here. Okay. All right, what do you guys get? 4 factorial. 4 times 3 times 2 times 1, 24. That's also, again, remember the number of ways of arranging 4 items. We can also find this using a tree. Right? So there's 4 options for the first thing, and then off of each of those. Here I picked one, so there's only 3 options for the second one. And then once you pick that, there's only 1 option for the 2 options for the next one, and then after that, there's only 1 option for the last. All right. In a horse race, the top 3 finishers in a horse race are recorded. right? Generally in horse races. You guys with me? So in a horse race, top 3 finishes are generally recorded. How many options are there for first place? If there's 8 horses in the race. Only one? You know ahead of time who's going to win? That'd be easy. There's 8 options. 8 horses in the race. Any one of them could win. There's 8 options. Everybody feeling okay with that one? Now, one horse comes in first. How many options are there for second place?
7.
7. How about for third place? 6. Good? So that should be coming up any second now. So, if I want to find the probability, how many options there are for the top 3 places, I would go 8 times 7 times 6. Does that make sense?
Yeah.
And I'd get, I think it's 336. 2 times 8. Yeah. Okay. This is what we call a permutation. It's when you cannot reuse items. Right? Once a horse comes in, he can't come in again. This is different than the digits because you can have it the number 0, 0, 0. You can't have the same horse win first, second, and third. So you cannot reuse items. What you do is, and order matters. So it matters who comes in first, second, or third. So here, this would be what we call 8P3, or sometimes it's written like that with a P with the parentheses and the 8 comma 3 there. Do you guys see that?
Yeah.
What that means is you have 8 items and you're picking 3 of them. So the easiest way to do that is start with 8 and I'm going to multiply down 3 spots because that's how many ones I'm picking. You guys see what I'm saying? It's exactly what we did, right? We're going to start with 8. And how many things are we picking? 3. So we're going to go 8. So what I would say you do is, you know you're going to pick 3 of them, draw 3 lines. Start with 8 and multiply down. Boom, boom. Yep, 7 and 6. You guys, everyone kind of follow me? Start with 8 and just multiply. So if you're going to pick 3 of them, draw that many lines. Start with the first number and just multiply down until you run out of spots. Good? This one's super straightforward. Permutation is really just a variation of the fundamental accounting principle when you cannot reuse items. So you're going to it's going to go down 1 each time. So now, a horse race has a race has 8 horse. A race has 8 race horses in it, but I want to record the finish of all of the horses. How many possible finishes are there? Well, how many options for the first place? 8. How many options for the second place?
7.
How many options for third place?
6.
Oops, sorry. Fourth place?
5.
Fifth place?
4.
Next?
3.
Next?
2.
Last? Does that make sense? So, another way of looking at this is how many ways, don't worry about it, it's fine. How many ways can you take 8 horses and arrange them? Right, come in first through 8. So again, arranging is what? 8 factorial, right? So it's 8, you multiply all the way down. So 8 factorial is really just a special case of 8p8. It's a permutation where you pick all of them. All right, you guys feeling okay with permutations?
Yeah.
Here's an example. Radio talk show host can select 3 of 6 special guests for a program. The order of appearance matters. It's important. How many ways can she do that? I knew that was going to happen. You know what? Let's do this. Let's let you guys try one. I want you guys try lab problems 6 and 7. Problem 6 and 7. All right, so let's take a look. I'm going to do my example. Maybe that will help us. A radio talk show host can select 3 of 6 special guests for her program. Order matters. So how many is she picking?
3.
3? So she's making 3 decisions. 1, 2, 3. Everybody on board? How many options does she have for the first spot?
6.
6. Now, can you reuse people?
No.
No. So how many options for the second spot?
5.
And the next spot?
4.
Good. You're going to multiply these. Is that everyone on board? So here we're going to pick 3 items out of 6. So if you're kind of thinking of this sort of permutation, 6 would be my N, and 3 would be my R. Permutations, hold on a second. Yep. So permutations, your thing talks about, has like NPR equals, right? I would do this. This is what I'd like you guys to write for your definition of permutations. I think the easiest thing to do is not to use a formula, but to write a description. So I would say, start with N, and then multiply down R spots. Because that's just what makes most sense, right? So here, I'm going to start with 6, and I'm going to multiply down 3 spots. 6, 5, 4. Done. Does that make sense for folks?
Yes.
So this, I think, is a lot. The book is going to show you a formula that makes no sense. I mean, that's not intuitive at all. And I think rather than memorizing another formula, which I think is ridiculous in math in general, it's better to understand it and just know how to do it because you understand, the ideas behind the situation. All right, so lab problem 22. 7 exterior colors, 3 interior colors. So that means I have 7 possibilities for my exterior color, and then from each of those, I have 3 possibilities for my interior colors. Right, so we got 7 times 3, and then 3 interior styles. So times another 3. Transmission can be either manual or automatic. 2 top choices. And then engine can either have 4 or 6 cylinders. 2. It's either 4-cylinder or it's a 6-cylinder. Good? I don't really care what you get, but you understand you multiply those numbers, yeah?
252.
Okay. Thank you. All right, we're going to move on. This one here, 3 door prizes are awarded. 112 people put their name in. First one drawn gets a trip to Vegas. Second one gets a dinner for 2. Third one gets a $10 gift card. All right, so how many choices am I making? 3 choices. You cannot reuse people. You can't win more than once. So it's going to be 112 P3. Everybody on board?
Yes.
So what am I going to do? I'm going to draw 3 lines. And how many options for the first spot?
112.
Second spot?
111.
Third spot?
110.
Good? Does order matter?
Yes.
Yes. I'd much rather have a trip to Vegas than a $10 gift card. Order totally matters. So does everyone understand that? Right? These are not the same thing. Gift card, trip to Vegas, not the same. Okay. Now, that's permutations, pretty straightforward. Now we're going to look at what happens if order doesn't matter. Order doesn't matter. So here, I'm going to pick 3 chaperones for a field trip. I've got Alex, Ross, Laura, Rigo. How many ways can I pick 3? Does order matter?
No.
No, they're all, I'm just going to grab 3, they're going to come with us. So, there's 4 ways. Think of it like not Alex, not Ross, not Laura, not Rigo, right? They're in purple, blue, red, and green. Those are the 4 ways. So there's 4 ways. Everybody on board?
Yeah.
What if order did matter? I have 4 people. I'm choosing 3. How would you find that?
4 times 3 times
4 times 3 times 2. Start with 4, multiply down 3 spots. Everybody okay with that part? That'd be 4 times 3 times 2, 24. Okay? Now, how do I get, oh, sorry. How do I get, whoa. Oh, so first of all, say I picked Alex, Ross, and Rigo. How many ways can I arrange them? If I want to put them in order.
Oh, you
How many options for the first spot? So say the first guy is going to check people's names off. The next one's going to count the students, and the third one's going to collect all the lunches. So how many options for the first spot? Second spot? Last spot? 6. Okay. How do you find out factorials again? 3 exclamation point. Okay, good. Just checking. Okay. But in our situation, order doesn't matter. All right. So if order matters, there's 24 options. These are all 24 options. I'm having 3 people, I'm picking 4 of them. Everybody good with this? How do I get from 24 to, if order doesn't matter, there's only 4 ways. How do I get from 24 to 4? I divide by 6. Why do I divide by 6? I would take 30 seconds with your neighbors and talk about it. Why do I divide by 6?
There's 4 people. Oh. I counted names, so it's 30 people. I was like,
The color matters. The color totally matters.
I don't know why it was divided by 6. Because I was like, yeah.
All right, what do you guys think?
Yeah, because those blues are different.
Any ideas?
There's 6 different combinations per color.
Yeah. So if you look here, this is just Alex, Ross, and Rigo arranged different ways. This one is just Rigo, Ross, and Laura arranged different ways. This one's just Alex, Laura, and Rigo arranged different ways. And this one's just Ross, Laura, and Alex arranged different ways. So really, there's just 4 groups if you don't care about the order. So you understand? So in a sense, the 6 tells you how many people are in a group. Does that make sense? In other words, how many ways can you take 3 people and arrange them? Good? So that's the deal. That's what this combination. That's what it means. It means you take 4C3 is really just 4P3 divided by the number of ways of arranging 3 people, 3 factorial. To simplify it, you'd write NPR. I'm sorry. 4 let me try this again. What's saying is if order doesn't matter, just find the permutation and divide by the number of ways of arranging our items, our factorial. I'm panicking because I only have 1 minute left and I know it. Okay, don't look at the clock, it's fine. So if order doesn't matter, and the way you kind of figure out the C's and the P's, one of my students said she thinks of chaos because order doesn't matter, they're all rolling around going wherever. Then it's NCR, so write this on your notes under the NCR is equal to NPR divided by R factorial. Right? If you want it in words, then you would say, start with N, multiply down R spots, then divide by R factorial. That's the number of ways of arranging R items, right? All right, so that should be good. That's all the information you need to know for the exam. I will see you guys on Monday. Yep. Monday review session at 4. Come early.
Thanks for letting me use your phone.
Oh, you're very welcome.